Okay, Algebra 2, we got a little Unit 7 review of everything in Unit 7. All right, so it should be May 14th. Okay, I put the worksheet together and I got this out and in and out thing. Why? Because things are either on the outside of the function, like here, +5 is on the outside, or you got a +5 is on the inside the parentheses. So I want you to see the difference as we go through. So in lesson 1, you should have figured out, or learned here, that if it's on the outside, what does it do? It moves you up or down. And it doesn't lie to you. It's on the outside. So if I see a +5, I'm going to shift up 5 units. So where's 4, 6 going to go? Let me draw a little picture here. Over 4, up 6, right? And then I'm going to move it up 5 more units. It's going to end up being higher. So it's still going to be over 4, but now it's going to be up 11. Okay. Well, what if the +5's on the inside? Well, parentheses lie to us. They lie. So we know that this is not going to move in a positive direction. First of all, it's going to go left to right. But the +5 is not moving to the right. It's moving to the left. It's going to shift 5 units left. So again, draw yourself a little quick picture here. Over 4, up 6, right? There I am, 4, 6, and now I'm going to move to the left 5 units. I'm going to come over here. Where am I going to end up? So if I move 5 units to the left, it only affects the x-axis. I'm going to end up at -1, 6. You know, even if you don't have graph paper, you can kind of figure this out. I'm moving to the left. I'm just moving to the left. So it's only going to affect the x-axis, the x value. All right, then lesson 2 was about negative sides, basically. So if you had a negative on the inside, or if you had a negative on the outside, or let's try that again, on the inside or on the outside. So if it's on the outside, again, what happens here? Think about this. Like if you had x squared, that's an upward parabola. And if you had negative x squared, what is that? Hey, that's a downward parabola. Well, what happened? It reflected. Why? It reflected over the x-axis, and that's what this is. Reflects over x-axis. So again, I took this coordinate 4, 6. Try to fit this in. Over 4. Up 6. There it is. It's in the first quadrant. When I reflect that, it's going to end up down here in the 4th quadrant. Where's it going to be? Still over 4. Now it's going to be down 6. Over 4. Down 6. So when you reflect over the x-axis, what happens? X stays the same and the y changes. See, that's tricky. I think that's a tricky thing. All right. What if it's on the inside? It's the other reflection. Reflects the y-axis. All right, so if you took your coordinate, over 4, up 6, and now you flip it, where's it going to be? It's going to be over here in quadrant 2, and now it's going to be back 4 and up 6. Back 4, up 6. So again, what happens? Reflecting the y-axis, y stays the same, x becomes the opposite. You learned this last year, geometry, but I'm doing it again this year. What was lesson 3 about? It was the vertical, and if it's on the outside, if you put a number on the outside, so for example I got a 2 here, what does that do? That's going to vertically stretch by 2. Now there's a half there. I don't know, Kirk might say you vertically stretch by a half or something, which makes no sense to me. You compress. So if I see a small number out here, it's going to shrink it, it's going to make it smaller, but if I get a big number, 2, 3, 4, it's going to vertically stretch it. So now, vertically means it only affects the y-axis, okay? So the 4 stays 4, and the 6 becomes a 12. Now, this is where it gets confusing, because I know what you did last year in geometry. You did dilation of 2. Where would 4, 6 move? If you did a dilation of 2 last year, it would go to 8, 12, and some of you are still doing that, okay? Wrong. We're not doing dilation. We're doing vertical. Only affects one of these coordinates. The vertical affects y. So the 6 becomes a 12, the 4 stays the same. Okay. What if the 2 is on the inside? Now don't forget, parentheses are lying to me. So I'm not going to be stretching. I'm going to be compressing, they call it. And it's going to be the horizontal. Horizontal, I say compress. It's going to get smaller by the reciprocal, a half. If that was a 3, it'd be a third. So we're only going to affect the horizontal, which is the x coordinate. The 4 is going to become a 2. It's going to become half, and the 6 is going to stay 6. Okay, that was a tough lesson, lesson 4. All right, in fact, 2 and 4 I think were the 2 tough lessons. Now we did lesson 5. You didn't do it recently, but we did it quite a while ago. If you look in your notes, you should have it all filled in already. And what was that about? Even and odd. So what is an even function? Opposite input gives the same output. Opposite input gives the same output. What's an odd function? Opposite input gives the opposite output. And I think I told you, you see a lot of O's. Opposite, opposite output, then you have an odd function. Opposite input gives you the same output, that's even function. I'm going to skip over this for a minute. So where does 4, 6 go? All right, opposite input, -4, where's it going to go? To the same output, 6. As opposed to over here, 4, 6, the opposite input, 4, where's it going to go? To the opposite output, -6. All right, what kind of transformation is this? The x changes, but the y stays the same. We just saw that. The x changes, but the y stays the same right here. It's the same as reflecting through the y-axis. So an even function, what is that? That's a reflect through the y-axis. So you might say, well, it's an odd function. Maybe that's a reflection to the x-axis. It's not. It's a rotation of 180 degrees, which we don't really do a whole lot of rotation. It's actually a double reflection. It's reflecting through x and y, but that's what it is, a rotation 180. All right, so this is a good summary. This in and out. Use this to help you on the Delta math, on the CASEL learning. Refer back to this. This could help you to understand things. We're going to go back and do a few questions here. All right, I got this function f of x. I'm affecting it 3 ways. What 3 transformations are? Why 3? Because I got a negative that affects it. The 2 is affecting it. The +4 is affecting it. It's all on the outside. So you see, it's all on the outside. It's only going to affect the y coordinate. Okay, the x is not being affected. So what's the negative do? What kind of transformation is that? In other words, list their order. I don't know. Oh, that sentence got cut off over here. Sorry. All right. So what's the first transformation? We have a reflect through the x-axis, reflecting over the x-axis. All right. And then the 2, what does that do? That vertically stretches by 2. Vertically stretched by 2, multiply by 2, not add 2. And then we have a translation. So it's going to translate, it's going to shift me up, shift up 4 units. That's adding. This is multiplying. This is adding. So I took a couple points, just made a couple points up. So if you did these 3 transformations, where would they go? What would happen? So -6, -2, if I reflect across the x-axis, remember, you gotta think about this. Let's draw a little picture. If I get stuck, that's what I do. I say, all right, if I was back 6, down 2, right there, down 2, and I reflect across the x-axis, where's it gonna go? So it's gonna go there. So it's still gonna be -6, but now it's gonna be +2. And then I wanna stretch it by 2, I'm gonna double it. Oh, then it's gonna go, -6 is gonna double, it's gonna go up to 4. It's going to go higher. And then if I shift it up 4 more places, where's it going to go then? Oh, -6, 8. See that? So you could try this on your own, but I'm going to just keep right on going. You can pause the video and try it. But now we're going to take -3, 2, do the same thing. You can draw yourself a little picture again. So if I had -3, back 3 places, up 2, and I reflect it, where's it going to go? It's going to go down here. -3, -2. It's going to reflect. It's going to come down here. Then I'm going to double it. So it's going to go further away. So it's going to go -3, -4. I'm going to double the y coordinate. And then but now I'm going to shift it up 4 places. So it's going to end up at -3, 0. Because I'm going to add 4 to that. Add. So you see I'm only affecting y because everything's on the outside. It's on the inside, it affects x. All right. So let's go to the next one here. Oh, I got something on the inside. It's going to affect x. Okay. But parentheses lie. So what's the first thing it's going to be? It's going to be a lie here. It's going to be a horizontal. It's not going to stretch it by 2. It's going to compress by half. It's going to be half the size. And then this -4 is on the outside. Oh, that's going to shift down 4 units. All right, so where's 8 -4 going to do? Okay, horizontally compress it. So half of that would be 4. Then the y coordinate stays the same, only affecting the horizontal. And then I'm going to shift down 4 units. Shift down 4 units. Oh, down means the y coordinate. So 4, -8 is where I would end up. Okay. F of 2 is 7, and there's a typo here. 5 f of 2 minus 2 f of -2. But we know it's an even function. So what do you know if it's even? -2, opposite input's going to have the same output. So what is 5 times f of 2? 5 times what? Well, f of 2 is 7. Minus 2 times f of -2, going to have the same output, 7. So I'm going to get 35, take away 14, which is 21. Now if I put the word odd there, then this would be a negative output, and that would be -7. So you got, that's the difference between even and odd. All right, the minimum point is 4, -3. So again, I'm going to draw myself a little picture. 4, -3 over 4, down 3. 1, 2, 3. All right, there's my minimum point. What happens if I do this? Well, first of all, +2 is really going to move me left 2 places. It's going to move me left 2 places. All right, and this is going to move me down 3 places. Down 3 places. So I'm going to take this coordinate, 4, -3. I'm going to move left 2 places, and that's going to bring me to 2, -3, and then I'm going to move down 3 places. I'm going to end up at 2, -6. That's where I would be, 2, -6. If you had a piece of scrap graph paper, it would be helpful. All right, this last one. Got some weird looking function here. I don't want the domain and range of the original function. I want, if I shift it again, how am I shifting? +3 means I'm moving left 3 units, and I'm also going to go down 2 units. So if you took this beginning point, moved it 3 to the left, 1, 2, 3, and down 2, right there. Took this end point, moved me 3 left, 1, 2, 3, down 2. You did the same thing last year with like triangles. Did this kind of shifting. Let me take some other points, like this point here. Move it 3 left, 1, 2, 3. Do that right? Yeah, down and down 2. And maybe I'll take this high point right there. Move that 3 left, 1, 2, 3, down 2. All right, so I'm going to do a lousy job of trying to draw this thing again. There it is. I shifted it. What's the domain of this thing? This shifted function. Yeah, let's see. It goes from 1, 2, 3, 4. Is that 5 or 4? That's 4. -4. How far over does it go? 3. There's the domain. And the range goes down -4, right? 1, 2, 3, 4, and up 3. Down -4, up 3. Just a coincidence that they're both the same. There's the new domain and range. Okay. Because I shifted everything. All right. So hopefully this will help. I hope the front side, you keep that handy for the next couple assignments that you got. That should help you out. The in and out, the summary of all 5 lessons. All right. Stay safe out there.